All right, so we're asked to evaluate this limit, right, as x approaches infinity. So this is quite straightforward, right? Now we're being asked basically how does this function behave as x gets bigger and bigger and bigger and bigger at its limit, right, which is at infinity. So at infinity, when the value of x gets infinitely large, how does this function behave? Well, we can approximately say that, okay, well, the number 9 is so small compared to infinity, right? So adding a 9 is not going to make a difference at all. So this function behaves as x over x, right? So we're just going to ignore this 9 because, these, as x gets really large, this 9 contributes less and less to the output, right? So we can approximate it with this. And from here, we can just continue. We can say, well, this is going to cancel out. And that's just going to be 1, right? And that's the limit of this. So let's do another one. Let's evaluate the limit as x approaches infinity of 3x squared plus 20x divided by 2x to the 4 plus 3x cubed minus 29. Okay, so again, we can just look at the highest power of these of these of these two equations and see how it behaves, because as x gets really 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 large, the x squared term is going to dominate the x term, and similarly x to the 4 is going to dominate the x to the 3 and this 29, right? So this behaves as if it's x squared over 2x to the 4, right? And then we can just simplify this down to 3 over 2x squared, right? And as x grows to infinity, this denominator gets bigger and bigger and bigger and bigger, and this 3 gets divided into smaller and smaller and smaller parts, which approximates 0, right? Because remember, when we're talking about limits, we're talking about how this function, how the output of this function over here behaves as x approaches some value, or in this case infinity, right? And as x grows larger and larger, this this numerator becomes smaller and smaller, and it approaches 0. It never gets to 0, but it gets really close, right? Okay, let's do one more. Let's evaluate the limit as x approaches infinity of 7x minus 9 over 4x plus 3, right? Now we're going to use the same logic, right? As x gets much larger than 9 and 3, they contribute less and less to the output, right? So this function essentially starts behaving as if it's 7x over 4x, right? And then we can just, these two cancels out, and this limit is just 7 over 4. Okay, so that's pretty straightforward. Hope that's clear, right?